material. Okay, I'm not drawing to scale. Okay, by the way. Okay, we have a material down here. Okay, so the material is in such a sense that it's like this now. All right, so this is the original. Okay, this is the original. Okay, so we know that this is made of aluminum. This is made of Kevlar, right? So these are all made of Kevlar. So now, because the fact that we have make aluminum our so-called reference material, right? So we make our material, right? So aluminum did not change, right? 3, right? 6, okay. Aluminum did not change at all. So now we decide to make the material out of what? Kevlar, right? We decide to make the, so what will change is the what? The height did not change. I repeat it. So the width, right? In fact, I should have put this over here so you all can refer better. So am I? Yep. So now what changes is the what? Is the width, right? So we change everything to become what? Aluminum. So now the width will grow what? The width will grow bigger. Only the what? Only the width, right? Only the width will grow bigger. Okay. The depth did not change. Okay. So now this is our aluminum. Okay. Just write in short ALU. And then this is Kevlar. Okay. So that's our Kevlar. Okay. So now I'm going to again I'm going to divide the structure now. Okay. So this is my, I'm going to call this my 1. Okay, then I'm going to call this my 2, 3, okay, and 4. Okay, 2, 3, and 4. Right. And
Eugene,
yes.
would section 4 not have to go wider as well?
Yeah, it has to. Okay, it has to go wider also. Okay, so I will redraw this. Okay, thank you for telling me that. Okay, I just realized that when I sketch. Thank you. So it will become like this. But the most important thing is what? The depth did not change. Okay. And I tell you guys why the depth did not change already. Okay. I think this is a better representation. Thank you, Jenna. Okay. So these are now all made of what? Aluminum. So Kevlar, Kevlar, Kevlar. Okay. So all these are Kevlar equivalent to aluminum. Okay. So I'm going to call this part 1 or 1, section 1, 2, 3, and 4. And I'm going to take the datum from the top. Okay, I'm going to take the datum from the top. Okay, so the datum from the top, my analysis from the top, and then it'll be sliding down. Okay. So now we're going to find centroid. Okay, we're going to find centroid. So in terms of geometry, okay, let me see, can I look at a geometry so you guys can see also. I'm going to copy. I'm just going to be temporarily pasting it down here so you can see the geometry, and then I'll wipe it off later. Okay. Okay, so that is the geometry. So likewise, nothing, not nothing changed. Okay, so this is a table that I will usually draw, okay, to find the centroid. Okay, it's not going to be any difference from the table that I've taught you guys before. So we're going to find the centroid. Okay, so again, section. So nothing changed. Okay, sorry, not nothing changed. I'll tell you what changed. Okay, 2, 3, and 4. Okay, then we're going to have okay, then we're going to have materials. Okay, so we know that this is aluminum, right? And then the rest are Kevlar, 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 right? And then over here, the next one, that's what I like to do is then I will put down the coefficient. Okay, and because we pick the coefficient to become what, to be an aluminum, so this is 1. Okay, and then the other one is 95 over 53, 95 over 53, 95 over 53. Okay, and then the
Sorry,
yes,
would you prefer us? We always keep the coefficient as a fraction if it's not an evenly divided fraction?
if you can keep it as a fraction, keep it as a fraction. Okay, so we will reduce the rounding. If you can't, round to 3 decimal points.
Okay, thank you.
Okay, and then you will have NW or NW. Yeah, so I'm going to put the NW together to highlight that the change is because of the width. Okay, so for the aluminum, you have 1 multiplied by 12, and the depth is 0.5. Okay, and then for the Kevlar, you have 95 over 53. So for that section, it's equal to 0.5. No, the depth, the width is 0.5. Okay, sorry. Today I'm not writing this right. I do apologize. Ay. 1, the width is 12. The depth is 0.5. Because if the table you got it wrong, wait, I'm not going to look at the look at the figure. I'm just going to derive my second moment of area, and I'll get everything wrong. Okay, so this one will be 95 over 53, right? So the width will be 0.5. The depth will be 6. This will be the same. Okay, and then the final one is 95 over 53. So the width will be 12, right? The width will be 12. The depth is 0.5. Yeah, the width will be 12. This is 0.5. Okay, so we calculate all this first. So this is 1. So this is 6, right? So 95 over 53 times by 0.5 times 6. This is equal to 285 over 53. The same. So 95 over 53 times 12 times 0.5. This will be equal to 570 over 53. Okay. So as I said, and you guys will see the advantage now why we did not change the height, right? This is the good news. The y bar, right? There's no coefficient beside, right? So this will be equal to 0.5 divided by 2, right? And then the other one is 6 divided by 2. 6 divided by 2. And the last one is 0.5 plus 6 plus 6. No, it's 6. Okay, I have to be careful. 6 minus by 0.5 divided by 2. Okay, so 6 minus by 0.5 divided by 2 is 5.75. And then finally, You guys will be expert on doing this by now, I think. Your final term over here is n width multiplied by d y bar. Okay, so 6 multiplied by 0.25 is 1.5. 3 multiplied by 258 over 53 is equal to 855 over 53. 855 over 53. All right, so it's 570 over 53 times by 5.75. Do you know why I leave them in decimal? I mean in fraction. Anyone? Why do we leave things? Why sometimes is okay to leave it in fraction if you can? Anyone?
It's more precise.
Yeah. There's no rounding now, is there? Right? So 1458. Who says it's more precise? Where you? No decimal. You're right. Okay. That's why sometimes fraction is good. Sometimes it's a mess. 1.5 plus 855 over 53 plus 855 over 53 plus by 6555. But sometimes you have no choice. Okay, you cannot get a fraction as an answer. So it's 5067 over 53. Okay. So now if we now do with our y bar, so will be equal to 5067 over 53 divided by 1458 over 53. Okay, so 15067 divided by 1458. So it's equal to 3.475 inches from the top. Okay, so 3 from the top, or okay, minus 6, 2.525 inches, okay, from the bottom. If you take the reference from the bottom, that is what we will get. Okay, so next, as usual, we're going to find IZZ1, IZZ2, IZZ3, and IZZ4. Okay, so IZZ. Okay, so that's why I hope you guys adopt this method of doing your table. So what you see me now, okay, I'm writing on my notepad. Okay, so this is my notepad. Okay, and what you see on your screen is what I see on my screen. Okay, what you see on the screen is what I see on my screen. Okay, so what I'm trying to highlight is this. Okay, I'm not even looking at the figure now. Once the table is right, everything is easy. Okay, that's why when you see the solution, they have a ways of doing it. It's so difficult to check whether you are right or wrong. They lump everything together and boom, pops your answer. Okay, so use this method, you have less error. Okay, so IZZ1. Okay, as I say, I'm not looking at what you see is what I see. Okay, so the width is 1 multiplied by 12, 0.5 cube divided by 12 plus by the cross-sectional area, and then multiply by 3.475 minus by 0.25 squared. Okay. So I did not even look at the figure. I just look at the table, right? So 12 times 0.5 power 3 divided by 12 plus by 6 times by 3.475 minus 0.25 close bracket squared. So your answer for this is equal to 60. I'll do it again. 1 times 12 times 0.5 power 3 divided by 12 plus by 6 times by 3.475 minus by 0.25 close bracket squared is equal to 62.528. Okay, so this is got 62.529. Okay, inch to power 4. Okay, I'll do it again. 3.475. 3.475. Okay, it's correct. So 1 times 12 times 0.5 power 3 divided by 12 plus by 6 times by 3.475 minus 0.25 close bracket squared is equal to 62.529. Correct. Okay. So now we do IZZ2. Now IZZ2 is equal to IZZ what? 3. Okay.